Alright, so I'm going to go over a few items on here just to make sure we're on the right track. So on here it just says find the average rate of change, which of course is the same as find the slope, right? We're not going to call it slope, we're going to call it average rate of change. So on all these we should have average rate of change. And we're still going to calculate the same way, especially for something that like this, that is just a linear graph, right? A straight line, finding a slope of it is no problem. So we could just go something like this, say up 2 over 1, and say the average rate of change is 2, right? And do make sure it's 2, not 2 over 1, right? We don't want that fraction. And then it says you're going to match the graph of the constant function that represents the average rate of change. So turn this slope into its own equation, such as like y equals 2, and match it with the letter down below. And you can see real fast that y equals 2 is right here, horizontal line, right? So that's going to be b. So we'll just put a b right there to know that those match. Technically what this we just graphed in calculus is called the derivative, when you actually take the rate of change from one graph and find that number and you make its own graph with it, right? So the graph of a diagonal linear graph is always going to be a horizontal straight line. All right, so that's just one little quick warm-up you have to do. Next is going to, again, find the average rate of change. It's going to give you different types of functions. Most of them are quadratic. They have a squared, so I'll do one of those. And so we always find the average rate of change. We're used to doing that. But this one also says find the equation of the secant line, okay, given 2 points. All right, so let's first find the average rate of change, and we'll talk about the second part. So as before, average rate of change is going to equal, we're going to use g here, and it gives us both x values. So we're going to use g of 6 minus g of 2, g of 3, over 6 minus 3. So that will just be, on the bottom anyway, will be 3. And then we have to find, g of 6, so we're going to take 6 squared minus 2 times 6, that's 24 minus 12. All right, so that's, that's 36 minus 12, which is 24. Okay, so that's 24 right there, and then we can do 3, and we have 3 squared minus 2 times 3, so that's 9 minus 3, so that's going to be 3. All right. And we can finish this up and calculate the average rate of change, which is 21 over 3 is 7. All right, so find the equation of a secant line. So the equation of a line, straight line, is going to have a slope, right? And that's what we're going to use for our slope. So you can think about 7 as a slope, right? And we have 2 points. So one of the problems on the summer review packet was practicing finding equations of lines as prerequisite number 1. So one way to do this is to use the point-slope formula. So if you have a slope, in this case an average rate of change, and any coordinate, then we can use this and just substitute values in. So right here for our slope, we'll use 7, and then you can use any coordinate, either coordinate I should say. Right, we have 2 of them, so you get to pick. So here we can use either, let's see here, 6, 24, that's one coordinate, or 3, 3. So just to keep things numbers smaller, we'll use 3, 3. And put my equal sign in, and there we go. Okay, so that is the equation of the secant line. Secant just means going through 2 points on a graph, that's all. So that's why it says secant line containing 2 points. Right? Now if it's a tangent line, so something like this, this is a secant line, that finds the average. Whereas if we had a graph like this and it only touched at 1 point, that would be called a tangent line. Okay, we only have 1 point on the graph. Okay, so very similar, close related. One has 2 points, one has 1. Now, what does this actually mean? It looks like this, but I want to show you on Desmos how you can use Desmos to help you out on these problems. Okay, So I'm going to open that up, and a graphing calculator will work as well. All right, so if you're into double checking things and you're not quite sure, you can always type in the function and actually put the g of x here, right, equals x squared minus 2x, right? Let's look at that. And it'll actually calculate what we just did. We had to find g of 6, so you can type g of 6 and it will actually give you the answer, 24. So we can do that for g of 3 as well, right? Gives us 3. We can actually do the entire slope, right? We can say m equal, we can't do m equals, but we can do, well, I'll just do the slope. Put in g of 6 minus g of 3 over 6 minus 3, right? And it calculates our slope. So we can use it for that. And let's just graph these 2 points. So we have 3, 3, and we have 6, 24, parentheses, right? And we can zoom out. Let's make these both the same color. And we can see those are the 2 points. And I'm trying to find the equation of the line that goes through them. So I used the slope, and I used 3 and 3, and you'll see that this line indeed does go through those 2 points. So we did find the secant line that goes through those 2 coordinates, right? Now you could have also used the other coordinates, right? You could have used 6 and 24, so just to show you, if I use that instead, it is also, at least it should be, the exact same line. So it doesn't matter which one you use, they are the same. Now because of this, it could look like you and someone else at your table group could do this and look like you have different answers. So for that reason, it's easier to compare if you just convert this to slope-intercept form, which means you want to get y equals mx plus b, right? So to do that, all you're going to do is distribute the 7 to the right-hand side. All right, so I'm going to do that first. 7x minus 18. Oh no, minus 21. There we go. And you notice I put 18 by x, and I thought, well, that doesn't work because it's not the same line. These should all be equivalent algebraically, so the graphs are equivalent as well. So as soon as it didn't match, I knew something was wrong. And then go ahead and add 3 to both sides. That's going to be negative 21 plus 3 is going to be minus 18. So now if we all agree to go to slope-intercept form, we won't have 2 different correct answers that all look like this. However, they all are correct, right? Either one of these in point-slope form or the slope-intercept form, they are all correct and would be graded as such. And so you get to pick which one you want to use. Slope-intercept down here or point-slope here. Either way, same graph. But at least you have a way of checking your work and understanding what it is your answer actually means. Right? That's the most important part, that we get down there. You can actually verbalize or write down what does your answer mean. All right, so that's a good use of Desmos there. You can always download the app as well. Let's see here. All right. Next, let's go on to the back. On here, it just does an interesting question. It says, for the general function, what does this mean? And it's funny because usually you are the one that's coming up with this, right? And the question is, find the average rate of change for the interval from 5 to 2, or 2 to 5, right? So really, they just flipped the script. They just said, well, we'll give them what's typically the answer and ask them what the question is. What does this represent? So that's all it is. It's the average rate of change of the interval from 2 to 5 for this function. Doesn't matter what the function is. We don't know if it's x squared or in 1 over x. Doesn't matter. It's just that's what it represents in all cases, in all functions. And that's all. So that's all these are. In this case, same thing. It's a secant line from these average rate of change for this particular function. Nothing more. All right. Now down here, it asks us to find where it's increasing, decreasing, and or constant. All right. So I'm going to start off with go over here. I'm just going to type in decreasing and increasing and constant. enough. All right, and write those intervals. Okay, so where is it increasing, decreasing, and support the answer with numerically. So that's going to be a little new part right here that I'm going to go over. Is what does this part actually mean, entail? All right, so decreasing. Let's take this. No, gotta leave it there. All right, I'm going to zoom out so you can see it. So decreasing, you can see on the graph, it decreases from here to here. So we can write the interval negative infinity to 3. And this is increasing from 3 all the way to positive infinity. And realize these are x values, so even though this is going up, we're not saying this keeps going up forever, therefore it's going to infinity, but that it keeps going right forever. So we're starting at x equals 3, and it'll keep going right forever, and that's what this infinity stands for, not that it's going up. Right? That's it. That'd be range. That'd be something else. All right, so how do we support this numerically? What does that actually mean? So there's a fancy way of writing something is decreasing and something is increasing. So what we do is we take 2 points where it's decreasing. Let's say at, let's say this is 1 and this is 2 right here. I'm going to do red. This is x equals 1 and x equals 2. Like, how would you actually describe that this is decreasing using numbers only? So the way we do that is we say if 1 is less than 2, as in x, this 1 and this 1, right, this 2. If 1 is a smaller number than 2, right, then the f of 1 is going to be bigger than the f of 2. What does that actually mean? All right, but this is how you want to look at it, is that this y value right here of 0 is going to be bigger than this y value at f of 2, which is negative 3. That's another fancy numerical way of saying, yeah, this is going down because since 1 is less than 2, but this f of 1 is bigger, you know, it's bigger up here than it is right here, that must mean that graph is going downward. And that's all you need to put, something like this statement. And we can do the same thing for increasing. I'm going to go over here. We can say if, pick any 2 numbers on the right side, let's say 4 and 5. So we can say, well, if 4 is less than 5, and it's increasing, f of 4 is going to be smaller than f of 5. It'll be less than, right? This y value right here is negative 3 is going to be smaller than this y value of 0 because it's going upwards. So as these numbers go upward, right, they get bigger. That's a fancy way of saying it's increasing. Okay, so it's just maybe a little new notation for you, but nothing we can't handle. All right, and constant, and we could just say this is not, no part of this is constant. Now for just completeness here, let's just say this was over here a constant part of a function. How would you actually write that? We would pick, again, 2 x's, and we would say, well, if 7 was less than 8, if it's constant, the f of 7 is equal to the f of 8. Right? Meaning those y values are both equal to 7 in this case, right? They're the same. So if they're the same, the y value is the same, that means, well, it's not going up and it's not going down, therefore it has to be flat and level, right? It has to be there. Okay, so that's just a bonus if this was in the problem, not actually part of the answer, though. Okay. All right, so hopefully that's a good explanation of those concepts. Practice them and help each other out when needed. Take care.